All right, what's up, guys? Welcome to the fourth review preview session for ENGI 1331. My name's Javi, and today we're going to be getting into loops. So first thing I want to cover is while loops, and then we're going to finish with an introduction to for loops. So what is a loop? A loop is basically just a block of code that repeats over and over so long as a certain condition continues to be met. So they're kind of like if statements in the sense that a condition must be met in order for the code inside of them to be ran. But now it's gonna be repeating over and over so long as that condition keeps on being met. So as an analogy, let's look at an if statement. So we always begin with the keyword if, followed by some condition, a block of code, say fprintf. So if this condition is met right here, our code's gonna run this block of code right here. If it's not, we're gonna skip over it, right? That's how an if statement works. So now keeping this analogy in mind, let's go ahead and talk about while loops. The syntax for while loops is pretty similar to if statements. Begin with the keyword while this time, and we're going to have some condition, x equals 1. And then we're going to have the same exact thing right here. So the main difference here, like I said earlier, is the fact that while loops will continue to repeat so long as this condition is met. So for example, let's go ahead and run this. So it prints out 1, right? Because x was 1, our condition was met, and we printed out 1. So now for the while loop, we run this. This code is just continuously printing out 1. It's not stopping. It just keeps going and going and going. And the reason for that is because we defined x as 1. We hit this while loop. X was 1, meaning the condition was satisfied. We print out 1. Then we end. Then we bounce back out to the while. Again, test if x equals 1. It does. We print out 1 again. And again and again and again and again. So to stop this, we're going to hit Control-C to kill the infinite loop is what it's called. So another example of an infinite loop is this. You see how, again, we have x equals 1. We satisfy condition x equals 1, and we print out yo. So if I run this, continuously keep on printing out yo because this condition is met over and over and over again. So we don't want to get stuck in these infinite loops, right? We don't want to get stuck in this because, it's not going to do anything for us if we get stuck in an infinite loop. To prevent this, you always want to make sure that this variable, I like to call it the condition variable, is always able to be manipulated inside of your while loop. So by that I mean, say x equals 1. While x is equal to 1, we're going to print out yo. I want to give the user a chance to change this. So something as simple as this. You want to print again. Yes. No. And so now, when I run this, x is defined as 1. We hit the while loop. The condition is satisfied. We print out yo. Then we test this right here. And so a menu will pop up asking us, do we want to print again? If we say yes, x becomes 1 since it's the first choice in our menu, and we run this again. So I'm going to click run. We get the menu. Do you want to print again? Yes. Got it again. Yes. Again. Yes. So now if I push no, x will then be defined as 2, since it's the second choice in our menu. And our while loop stops. Our code ends. So as you can see, x was 1. We hit the condition, satisfied it, printed it, ran it as many times as we wanted to. And then when we said no, x was then defined as 2 on this line. And so when we hit this end, we bounce back up to the while. Does x still equal 1? No. So then we skip this, and we move on in our code. So the main point I'm making here is always make sure any variable in a condition in your while loop is able to be manipulated from within your while loop. If not, you're just going to keep repeating over and over because this is always going to be satisfied. So let's look at some applications. So what if we want the user to enter a number greater than 10. Usually we would have you guys validate this with an if statement. So we usually do this by saying x becomes the absolute value of x if x is greater than 10, or is less than 10, excuse me. We would usually tell you guys to either produce an error or we would tell you guys to do something along the lines of assuming the value. So x becomes 11, the closest value, the closest integer greater than 10. But now, with while loops, we can continue to ask the user this question until they input a valid input. So, while x is less than 10. We can just put this in here again. And so now, we first ask the question, enter a number greater than 10. We take the absolute value of that number. If that value is still less than 10, we ask again. We take the absolute value. Then we hit this end, we bounce back up to the while, we test this again. If it's still less than 10, meaning the user again inputted an incorrect value, we're going to keep asking them over and over and over again. So enter a number greater than 10, right here. Let's say 4. The absolute value of 4 is 4. While 4 is less than 10, we run this. Enter a number greater than 10. So we're right here right now. If I say 4, or if I say, let's say 6, x becomes 6 on this line. The absolute value of 6 is 6. And bounce back up to the while. X6 is still less than 10. We run it again. And to see, it asks me again. So no matter what number I enter, if it's less than 10, my code will not accept it. And so if I pick 11, x becomes input, enter a number greater than 10. We entered 11, x becomes 11. The absolute value of 11 is 11. And is 11 less than 10? No. So we skip this. We move on. So say we wanted to only give the user 3 chances. Okay? While x is less than 10 still. And let's say count is less than 3. Okay? And let's define count as 1. So here, we get into our code. We ask them to enter a number greater than 10, take the absolute value, and we define count to be 1, meaning we asked them 1 time so far. While x is less than 10, meaning they did not enter a correct number, and count is less than 3, meaning we have asked them less than 3 times. I'm going to put this in here again. But instead, we're going to say count becomes count plus 1. So now we ask them the first time, count becomes 1, while x is less than 10 and count is less than 3. So let's say we enter the wrong number. We ask them again. We take the absolute value of it, and count becomes count plus 1. So now we've asked them twice. And if it's still wrong, we bounce back up. It's still wrong, and count is now 2. We ask them again. Count becomes 3. So we bounce back up. If we still input something wrong, but count is now 3, which is not less than 3, we're going to skip all this, right? Because this was not satisfied. And so now all we can say is if x is still less than 10, so we run this, enter a number greater than 10, 2. Absolute value 2 is 2, count becomes 1. This condition was satisfied since 2 is less than 10, and count, which is 1, is less than 3. So we jump into this while loop. We ask them again, which is where we are right now. Let's say 3. Absolute value is 3, count becomes now count plus 1, so count becomes 2. We hit this end, we bounce back up. Is 3 less than 10? Yes. Is 2 less than 3? Yes. So we ask them again. So now we're here. Let's say 5. We get the error we want. We said 5 here. The absolute value of 5 is 5. Count becomes 3 now. Hit the end, bounce back up. Is 3 less than 10? Or I mean, is 5 less than 10? Yes. But count is now 3, which is not less than 3. So now we bounce out of this while loop. Since this was not satisfied, we go to this if. If the user still input the last input, which was 5, is still less than 10, then we error because we gave them those chances. With this example, we can see that we can both put multiple conditions in a while, just like with an if. And we can also use this to gauge how many times the user has been asked. So maybe we don't want to produce an error times we ask them. So this would be count, right? 2, 2, 3, 4. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You had to ask 11 times. So another example of a while loop would be a control loop. So here's an example of a control loop. This example is a basic heads or tails game. So what our code is doing is taking a random number from 1 to 2, meaning heads or tails, heads corresponding to 1, since our menu is 1, or it's our first choice in the menu, and tails corresponding to 2, since it's our second choice in the menu. And so we defined a to be a random integer from 1 to 2. If u, heads or tails, equals a, so if I chose 1 here and the random integer happened to be 1, this is our coin flip. It's either 1 or 2, heads or tails. If I chose heads and our coin flip turned out to be heads, then I won. And so it would also work for tails. If I pick tails and this random integer happened to be 2, then I won because u would equal a. If not, then I lose. And so the reason we call this a control loop is because right here, you see that the condition, again, is asked again inside of the while loop. So what we're saying is, again becomes menu. Would you like to play again? If I say yes, corresponding to 1, again becomes 1. I end. I go up to the top of the while loop. Again still equals 1. And so we just run this again. If I were to say no, again would then be 2. And jump up to the while. Does again equal 2? No, 1? No, it equals 2. So we kill the while loop. Let's try it. Heads or tails? So we're right here. Tails. I won. So if I say no, my while loop ends. And you'll see a, which is the random integer from 1 to 2, happened to be 2. And I chose tails, which corresponds to 2. So u would equal a, and we won. And then we said no. So again, was 2 until we bounced out of the while loop. And so I can do this. I can play over and over and over again. I chose heads, I lost. Yes, I'd like to play again. Chose tails, I lost. Play again. Tails, I won. Whenever I say no, the while loop ends. So the reason it's called a control loop is because our user is actually controlling if they want to play again and again and again and again. So the next section I'd like to get into are for loops. And so you've seen while loops through the past few weeks of class, or the past week of class before the exam, but for loops are going to be a new topic in this coming week. So the definition of a for loop is it's a loop, right? So it repeats over and over and over again, it loops, right? But in this case, we can now define however many times we want this loop to go. Okay, so and what we say is we can define how many times we want this loop to iterate, how many times we want it to run over and over. Okay, so here, this while loop runs however amount of times we say yes to this menu, right? But here, no matter what we do inside of the loop, it will run a certain amount of times. So this is a for loop right here. As you can see, it begins with the keyword for. This is what I like to call a counter variable. And this right here defines the range of what the counter variable will equal. This is just a block of code inside the for loop, and this is our end statement. So this right here is basically just like a vector. So if I were to say vector v becomes 1 through 10, we can also define our iteration. So starts at 1, jumps 2 every time, stops at 10. We can also do that here. So it jumps 2 every time, stops at 10. But in this case, usually we would be saying, if we say this, v equals a vector from 1 to 10, right? But in the case of a for loop, every time this loop iterates, meaning every time it repeats itself, this value or this variable I will hold a different value in this range. So during the first iteration, I will equal 1, where it starts. Then after the first iteration, we hit the end, we bounce back up, I then becomes 2, the next value in the range from 1 to 10, and so on. So it'll end with I equaling 10. So as you can see here, we run this, we hit this for loop. I is set to 1, where it starts. We fprintf I equals whatever it equaled, which was 1 in the first case. Then we hit the end, we bounce back up to the for loop. I now equals 2, so we print out 2. Then 3, and then 4, and then 5, and 6, and 7, and 10, all the way to 10. And so as you can see from this, so let's say we run this. This for loop will run all the way till I equals 10, so to completion, and then it'll move on to what's next in the code. And I mean, so it's just like a while loop, right? The while loop would keep running over and over until our condition wasn't met. And we'd end and bounce out to whatever was next in the code. In this case, all we're doing is running till we tell it to stop, so at 10, and then we print out what's after it. We move on to the code. And so, like I said before, every time this for loop runs, I is a different value in the range from 1 to 10. So when it first runs, it's 1, and then it's 2, then it's 3, and so on. Now, in changing up this range, so say we want to go 2 by 2 to 10. So we start at 2, jump 2 every time, and we start at 10. So I was 2 during the first iteration of our loop. We printed out 2. Then when it ran again, it jumped 2 to 4, and then 6, and then 8, and then 10. But notice how we only had the loop run 5 times. Because in the range from 2 to 10, when we jump to 2, or we jump by 2, it would look something along the lines of 2, 4, 6, 8, 10, which is a total of 5 numbers, right? And so as you can see, however many numbers we have in this range is however many times this for loop runs. But during this for loop, I took on a value from 2 to 4 to 6 to 8 to 10. But it didn't run 10 times. It ran only 5 times. So as you can see, by changing up this range here, we can define however many times the for loop runs, and we can define also the value of what I is going to be. So in this example, I'd like to go over indexing from within a for loop. So v is a vector, 23, 56, 46, 25, 78, 82, and 22, just a random vector. Say I want to create a for loop that prints out every value in this vector separately. How do we do that? So we know we're going to have a for loop. We're going to say some variable I, our counter variable, becomes a range from 1 to what? How many times do we want this for loop to run? We want this for loop to run however many times corresponding to however many values we have in V, right? So first we need a variable that stores however many values we have in V, right? So let's say L is the length of V. We want this to run from 1 to L. So now all we have to do and so we're going to index V if we want to print out every value separately at I. We're going to end this. So what this is doing is first we're defining a vector V. We're taking the length of it and we're storing it in L. We hit this for loop. I starts at 1, jumps by a default increment of 1 since we didn't define 1, and stops at L. So when we fprintf out, we print out V at I. So in the first iteration, we V at 1, which is 23. Then after this, we jump back up. I becomes the next value in this set, which is 2. So V at 2 is 56. We print that out. And so you'll see, we print out this whole vector. And so what we're doing here is we're basically using a for loop to index inside of this vector. Right? And so we could do more than just print it out. We could have an if statement, say if V at I is greater than, let's say, 50. V at I becomes 0. And so now inside of this for loop, we're using I to move from value to value inside of V during every iteration. So I is 1 in the first iteration. If V at 1 is greater than 50, it's not. So we end. We bounce out of this if because this condition was not met. We print out 23. The second iteration, V at 2, is it greater than 50? Yeah, so it's going to become 0, and we're going to print out a 0 instead of 56. 46, not, so it stays, 0, 0, stays, right? So if we run this, 23, 0, 46, 25, 0, 0, 22. And so what we can do is we can go value to value within this vector and manipulate the values inside of the vector and then print out the values inside of the vector. You can also do a lot more things with for loops that you're going to see in class this coming week. So lastly, I want to get into nested for loops. So notice how earlier I said how this for loop is going to run all the way to completion, and then we're going to print out whatever's after it. So we did 2, 4, 6, 8, 10. So this for loop ran over and over and over again until it was finished. We hit 10, and then we printed out done, which is after the for loop. So keeping that in mind, if we have a matrix M, and we want to print out every value in this matrix separately, how are we going to do that? So last time we talked about the vector, and we needed the length of that vector. So I presume we're going to need to do something with the size of M. So let's just take the size of M. Okay. Create a for loop, since we did that for the vector. I'm going to do it for this one as well. 1 through, let's just start with rows. So now this for loop right here is going to move from 1 all the way to 4, since that's, or I'm sorry, 1 all the way to 3, since it's however many rows we have in M. So if we were to fprintf, so we run this, 23, 56, 27. And so what it did was it indexed M at I, which was 1, 2, then 3, since R was a maximum value of 3. And it printed out M at 1, 2, and 3. Because when we give a matrix only one index, it counts like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So we need to give it both the row index and the column index. Let's define another for loop inside of this for loop. We're always going to want to use a different variable than the previous one we used, because if not, we'd start this for loop. We'd say I equals 1 at the start, Then we hit this for loop. And if we use I here again, and say we had a different range, we would be defining I as something else. And so we don't want to do that. It's basically like the same thing as overwriting a variable before we use it. So we go through columns this time. And we say M at RC, row column. And then we end this. So if I run this, I did RC again, huh? This is supposed to be IJ. So I run this. I get 23, 45, 67, 89. Okay, so let's see what it did. Started at 23. We got 45 next. Then we got 67, 89. So it looks like we're going this way. So it looks like we're starting on one row. We're going row to next column, to next column, to next column. And then after 89, we hit 56. So it looked like we jumped another row. I goes through the number of rows. J goes through the number of columns. We printed out the value of M at IJ. So in the beginning, I would equal 1, J would equal 1. We printed out M at 1, 1. But now when we hit this end right here, we're going to bounce back up to this for loop, and J is going to change. So J would then be 2, but we didn't change I. So then we print out M at 1 because I was never changed, 2, since J is now 2 in the second iteration of this for loop. And so we printed out M at row 1, column 2. So it should go 23, then 45, 23, 45. And then it iterates again. J would then become 3, since C has a maximum value of 4. So then we print out M at row 1, because we didn't change I, and column 3, since we changed J, so 67. And so as you can see, the innermost for loop runs to completion. Because at the end, we went to 89, we printed out 89. So this for loop right here ran to completion, but then it seems like after that, after we printed out 89, we bounced back out to 56, so we changed the row, which is exactly what happened. We finished this for loop, J finally finished at 4, then we bounced back out to this end, but this for loop hadn't finished. So we bounced back up to this for loop, I then becomes 2, and then we redefine J to be 1 again. Because it's not like we're repeating this, but we finished it, we bounced to this end, then we repeat this, which includes the definition of J being a value from 1 to C. So then when R equals 2, J becomes 1 again. We print out the value at I, which is 2, J, which is now 1 again, so 56. So after 89, we should have 56. And then this repeats again and again and again, all the way to 4. So then we should have 45, 76, 12. And then after this finishes for the second time, we bounce back out to this end. I then is defined as 3, the last iteration of this for loop. Then we hit this one again, and we redefine J as 1, and we run through the number of columns again.